Okay. Good day, viewers all over the world. Welcome to Toydel online class. So today we're still going to continue with matrices. So under matrices, I want to consider Crammers rule. When we introduce matrix, we talk about square matrix. That is, if you have a matrix A, B, C, D. If this matrix A, and this is a 2 by 2 matrix, so it's a square matrix. We've discussed, we know how to find the determinant of this matrix. That is, we said if we want to find the determinant of this matrix, it is the product of the leading diagonal. That is A times Z. That will be AD minus the product of the ordinary diagonal, BC. And that's how to find the determinant of a 2 by 2 matrix. So we can actually use the knowledge of matrix, like this Crammers rule that we want to discuss today. We can use it to find the solution to a set of linear equations. Linear equations in the sense that, for instance, if you have a simultaneous equation, in case of simultaneous equation, it's an equation that has two variables and two equations. They are linear variables. For instance, if you have something like 3x minus 2y is equal to 7, then if you have x plus 2y is equal to minus 3. So this is a set of linear equations in x and y. So, and it is called simultaneous equation. Why is it called simultaneous equation? It's the equation that has two, in this case now, it has two variables, x and y, and two equations, two linear equations. X is linear, x1, y1, x raised to power 1, y raised to power 1. These are linear equations. So we can use the knowledge of matrices to actually solve the solution, to actually get the solution of a set of linear equations. This one is linear. Of course, we can have something like, say, we can call it 3x1 minus 2x2 equal to 7. We can write it in this form. We can say x1 plus 2x2 is equal to minus 3. So this is also a linear equation. It's a set of linear equations because x1, x2, x1, x2. These are the two variables. Then we have two equations. We can also have three. We can have three variables with three equations. Also, the set is also a set of linear equations. We can have it up to nth variables and nth equations. So in this case now, what do we do? If you want to find, this is a simultaneous equation. In our basic knowledge, we know that if we are given a simultaneous equation, we can actually use either elimination method or substitution method to solve this type of problem. But I want to use the knowledge of matrices now, which is called Crammers rule, to solve this simultaneous equation. These two equations involving two variables. So this will be the first example. Then I will also use it to solve three equations with three variables. So let's just take example. Let's say this is example 1 under Crammers rule. Example 1: solve the equation, or you can say solve the simultaneous equation using Crammers rule. Okay, this is the equation. How do we apply Crammers rule to solve this equation? This is what we are going to do. Of course, we are going to use the knowledge of determinant of a matrix to solve this. So we write out the coefficients here. That is, where we have 3. The coefficient of x here is 1. The coefficient of y here is minus 2, and here is 2. So this is what we do. This is the coefficient of the variables. Then we can call it k. Let's call it k. Let's call the coefficient k. So we can go ahead and find the determinant of the coefficient. We find the determinant of the coefficient. That is, we find the determinant of the coefficient, and that will be k. Determinant of the coefficient will now be leading diagonal 3 times 2 minus, into bracket, minus 2 times 1. That's how to find determinant. Then 3 times 2 is 6 minus, this is minus 2. So we are going to have determinant of k to be equal to 6 minus x minus x plus 2 equal to 8. So the determinant of the constant is 8. That's the first step that we do. So once we know the determinant of the constant, then we go ahead and find the determinant of x. This is what we do. If I want to find the determinant of x, if I want to find the determinant of x, this is what I will do. The coefficient of x is 3 and 1. So for me to be able to find the determinant of x, I'm going to replace, instead of 3 and 1, which is the coefficient of x, I'll replace it with this constant here. I'll replace it with 7 and minus 3. Then I'll write out the coefficient of y, minus 2, 2. That's what you do. Look at, if you want to apply Crammers rule, the first step is that write out the coefficient of x and y. And if it is 3 by 3, x, y, z, write out the coefficient. Find the determinant of the coefficient. And that's what we have done here. We got the determinant to be 8. So if you now want to find the coefficient of each of the variables, that is x, if I'm to find the determinant of x now, instead of using the coefficient of x, I would disregard the coefficient of x when finding the determinant of x. I'm going to use the constant here equal to at the right hand side. I will use it to replace the coefficient of x. And that's what I've done there. So if you do that, if I say 7, I'm going to have 7 times 2 minus 3 times minus 2. So 7 times 2 is 14 minus 6, and that is equal to 8. So determinant of a also is equal to 8. Then we go ahead and find determinant of b, of y. We know determinant of k to be x. So what will be the determinant of y? Determinant of y now will now be, we write the coefficient of x. Of course, the coefficient of x there is 3 and 1. Now, instead of using the coefficient of y, which is 2, minus 2 and 2, I'm going to replace it with the constant at the right hand side. That will be 7 minus 3. So that's how to get the coefficient of y. Then if I do that, this will give me 3 times minus 3 minus into bracket 1 times 7. So I'm going to get minus, I'll get minus 9 minus 1 times 7 is 7. So that will be minus 16. So the coefficient of y is minus 16. So how do I get the variable x and y? I will now say, therefore, x is given as coefficient of x all over coefficient of the constant. Then y is given as coefficient of y all over coefficient of the constant. No, x is equal to determinant of x all over determinant of the constant. Y is equal to determinant of y all over determinant of the constant. So if you do that, then what will be the value of x and y? So therefore, x is equal to, determinant of x is 8 divided by 8, and that will give us 1. Then y will now be, determinant of y is minus 16 all over determinant of k is 8, and that will be minus 2. Therefore, x is equal to 1 and y is equal to minus 2. And that's what we are going to get. So we have used the knowledge of Crammers rule to solve the simultaneous equation. And of course, you can verify this from the given equation. You can use that substitution method or elimination method. At the end of the day, we are going to get the same thing. So we should know that even if we decide to use any other method, we must get the same answer at the end of the day. So that is how to use the knowledge of Crammers rule to solve simultaneous equation. So that's what we have done. But in this case now, in example 1, it's equation involving 2 equations and 2 variables. So I'm going to introduce another example where we have 3 equations with 3 variables. So how do we use Crammers rule to solve that? Example 2. So let's see a situation whereby we have 3 equations with 3 variables. So in this case, now the question says solve the equation, or let's say solve the set of equation. Solve the set of equation. So how do we solve that? Let me write out the equation. Solve the set of equations. So in this case, now instead of using x, y, z, we start to use x1, x2, x3. So we have 2x1 minus 3x2 minus x3 equal to 2. That's equation 1. We have x1 plus 4x2 plus 2x cubed is equal to 3. Then we have x1 minus x2 plus x3 is equal to 5. So in this case now, we have 3 unknown, x1, x2, and x3. We have three unknown, x1, x2, and x3. So of course, we can change the unknown to x, y, z. So in this case now, we have three linear equations. It's raised to power 1, or the unknown is raised to power 1. So it's a linear equation. So this is a set of linear equations. Then there are three equations. You know, in simultaneous equation, we can have three simultaneous equation involving three variables, x, y, z. And there will be three equations. So how do we solve that? We are going to use the knowledge of Crammers rule now. If we want to solve this now, what is the first thing that we are going to do? So that's what I'm about to introduce now. So for us to be able to use Crammers rule to solve this, we first try to, of course, we call all the variables, the variable of x, y, x1, x2, x3, we call it k. So we find the determinant of the variable. The variables of x1 are 2, 1, 1. When you check x2, we have -3, 4, and -1. Then if you check the variable of x3, that's -1, 2, and 1. So we go ahead and we are going to find the determinant. We'll find the determinant of this variable. So how do we get the determinants? Of course, if you have 3 by 3, if you want to find the determinant of 3 by 3 matrix, is that you use Crammers rule? No, is that you use the normal way of finding determinants, just put plus, minus, plus here, then we reduce this, or you use Saru's rule. In case of Saru's rule, we are going to repeat the first two columns, then you cancel out. Just you look for the leading diagonal, the three leading diagonal minus the three other diagonal, then you get your answer. So in this case, now I want to find determinants of k. How do I get out? Now this is what I will do. I will write out, if I want to find determinants of k, I'm going to write out the first one, the first entry, 2. What do I have left? Then in this case now, initially we have -3. Because of this minus now, minus is plus. So here will be +3. We write out the leftover. Then here I'm going to have -1. I'll write out the leftover. So if I pick 2 now, first row, and first column, what do I have left? I have 4, 2, -1, 1. So if I pick -3, that's first row and second column. You're going to have 1, 1, 2, 1. So I have 1, 1, 2, 1. Then I'll go ahead and pick the third column where I have -1. So if I pretend as if I cover first row and third column, I'm going to have 1, 4, 1, -1, 1, 4, 1, -1. So at this point now, I can get the determinant. So this will be 2 into bracket 4 times 1, that is 4, minus 2 times -1, that's -2. So I have -2. Okay. Then I have +3 into bracket 1 times 1, 1, minus 1 times 2, 2. Then -1 into bracket -1 minus 4. And that's what I'm going to get. So from here now, we have minus times minus is plus. 4 plus 2 is 6. 6 times 2, 12. I will have 12 plus 1 minus 2, that's -1. 3 times -1, that's -3. Then here I'm going to have minus times -1 minus 4, that's -5. Minus times minus is plus. So I'm going to get +5 here. So from here now, 12 plus 5 is 17, minus 3, that's 14. So the determinant of k is equal to 14. So we have got the determinant of k. So in this case now, the determinant of the variables, coefficient of the variables is equal to 14. So we have gotten the determinant now. So we now we go ahead and find the determinant of x1, because x1 is part of the variable x1. How do I get the determinant of x1? This is what you do. Instead of the variable, the coefficient, which is 2, 1, 1, I'm going to disregard this coefficient now. I will now replace it with the constant at the right hand side. I will replace it with the constant at the right hand side. If I do that, I'm going to have 2, 3, 5. Then in this case now, we follow the same step. So the first one is 2. The leftover is still intact. The second one is 3. So the leftover in this case will now be 3, 5. The leftover will now be 3, 5, 2, 1. Then the last one -2. So the leftover will be 3 and 5. Just replace this with 3 and 5. So we follow the same step. You're going to follow the same step. In this, I'm going to have 2 into bracket 4 times 1. 4 times 1 is 4, minus into bracket -2. That's what I'll get. Then plus 3 into bracket 3 times 5. 3 times 1 is 3. 5 times 2, 10. 3 minus 10. Then I have -1 into bracket -3. 5 times 4, -20. So from here, I'm going to have 2 into bracket 6. That's 2 multiplied by 6. Plus 3 into bracket -7. then minus 1 into bracket minus 23. So determinant of x will now be 2 times 6 is 12 minus 21 plus 23. So 23. So determinant of x finally will now be 23 plus 12. That's 30. That's 35. 35 minus 21, 14. So determinant of x1 is 14. So we have gotten determinant of x1. Then we go ahead and find determinant of x2. So how do we get determinant of x2? X2. If you want to find determinant of x2 now, we are going to write out determinant of x1, which is 2, 1, 1. So instead of the coefficient of x2, which is minus 3, 4, and minus 1, we are going to replace this with the coefficient of the right hand side, because we want to find the determinant of x2. That will be 2, 3, 5. And of course, we do the same thing. So here I'm going to have, instead of 3 now, it will be 2. So at this point now, if you want to find this, then this is what you do. We want to find determinant of x2 will now be, the determinant of x2 will now be, we pick the first one, 2 into bracket, the leftover will be 3, 2, 5, 1. Then in this case now, it's no longer minus 3, it will be minus 2 into bracket 1, 1, 2, 1, 1, 1, 2, 1. Then the last one, minus 1 into bracket, minus 1 into bracket 1, 3, 1, 5. That's what we get. So determinant of x2 will now be equal to 2 into bracket 3 times 1. 3 times 1 is 3. I have 3 minus 5 times 2, 10. Then minus 2 into bracket 1 minus 2. Then minus 1 into bracket 5 minus 3. So here I'm going to have 3 minus 10 is minus 7. Times 2, that's minus 14. Then here I have minus 1 minus plus 2. Then here I have 2. 2 times 0 minus 2. This will take care of this. So determinant of x2 is also equal to minus 14. So determinant of x1, let's notice somewhere, determinant of x1 is equal to 14. The determinant of x2 is minus 14. Then the determinant of k is 14. That's what we have gotten. So we move ahead to the third one, x3. So how do we get the coefficient of x3? So we first replace the coefficient of x2, which is minus 3, 4, minus 1. So instead of the coefficient of x3 now, because we want to find the determinant of x3, then instead of using minus 1, 2, and 1, we are going to remove that. Then we replace it with the coefficient of the right hand side, which is 2, 3, 5, because we want to find the determinant of x3. We replace this right hand side with x3. When we want to find the determinant of x2, we replace the coefficient of x2 with the right hand side. Then when we want to find the determinant of x1, we replace the coefficient of x1 with the constant at the right hand side. And that's what we do. So if you want to do that now, if you want to find the determinant of x3 now, you just say determinant of x3. That's what we are about to find now. Determinant of x3 will now be equal to, we have 2 into bracket. When we pick 2, the leftover will be 4, 3, minus 1, 5. Okay? Then this is minus, it will be plus. We have minus 3. That will be plus 3. That's plus 3 into bracket, plus 3 into bracket. The leftover will be 1, 3, 1, 5. 1, 3, 1, 5. 1, 3, 1, 5. Then we have 2 into bracket 1, 4, 1 minus 1. And that's what we are going to get. So if you do that, we have 2 into bracket. 4 times 5 is 20 minus 3. Okay? Plus 3 into bracket 5 minus 3. Then plus 2 into bracket minus 1 minus 4. So here I'm going to have 2 into bracket 23, because minus is plus. Then plus 3 into bracket 2. Then plus 2 into bracket minus 5. So I'm going to have 46 plus 6, this 6, then minus 10. So here we are going to have 52. 52 minus 10 is 42. So determinant of x3 is equal to 42. So how do we now get the value of x1, x2, and x3? So for us to be able to get the value of x1, x2, x3, then we just go ahead and complete the solution. So determinant of x3 is equal to 42. So x1 is given as determinant of x1 all over determinant of k, the constant that we first find. X2 is giving us determinant of x2 all over determinant of k, while s3 is the same thing, determinant of s3 all over determinant of k. So x1 will now be equal to, determinant of x1 is 14, so we have 14 divided by 14, x2 minus 14 divided by 14, then x3 42 divided by 14. That's what you get. So therefore, x1 is equal to 1, x2 is equal to minus 1, and x3 is equal to 3. So that's what you get. So we can actually use the knowledge of Crammers rule to solve any given linear equations involving any the number, irrespective of the number of variables. It can be 4 equations involving 4 variables, 5 equations involving 5 variables. As long as the equations are linear equations, set of linear equations, then we can actually apply Crammers rule to solve that. So I would love to stop here because of our time. In our next class, I will apply another method that we can actually use to solve set of linear equations without using Crammers rule. There are so many methods that we can use. I just tried to discuss Crammers rule today. There's another one called the Gaussian Elimination Method. We can also, what I've done here, example 1 and example 2, I can also use Gaussian Elimination Method to solve that. We have about 3 or 4 different methods that we can actually use to solve the set of linear equations. But because our concept for today is Crammers rule, so I've been able to show how to use Crammers rule to solve 2 by 2 simultaneous equation and 3 by 3 set of linear equation or simultaneous equation. So if this simultaneous equation, instead of x1, x2, x3, we can have maybe a, b, c, or we have x1, x, y, z. Then once we follow the same step, we are going to get the same thing. So thank you for listening.